Hi guys, today's quick peek lesson is going to be on improper fractions and mixed numbers. So we're entering in the final portion of our fractions unit, and up to this point we've been dealing with what we call proper fractions because the numerators, the top number, have always been smaller than the denominators, which is the bottom number. So now we're seeing how it looks like the fractions have been flipped. So now the numerators are larger than the denominators. So our general class definition of how we explain the importance of improper fractions and mixed numbers, we explain them by saying that improper fractions and mixed numbers are numbers used to represent fractions that are greater than 1. Because when we began to discuss fractions, we talked about them representing quantities that were less than 1. So now we're beginning to see how we can extend that learning to explore those fractions which are representing amounts that are greater than 1. Let's take a look at the first example. So this fraction is read 12/7 or 12/7. And our numerator here represents or tells us how many parts of the model will be shaded. So this tells us the number of shaded parts. So then the denominator, which is our 7 here, tells us the total number of parts in each whole. Alright, so let's see how that would look on the model. So I'm going to go up at the top and grab some color, and then I'm going to shade in the number of parts. So we're supposed to have 12 parts shaded. So I know each model has 7 parts. So I know that I need way more than 7. So I can go ahead and shade in all of this model. So that took care of 7 of the 12. So how many more do I need to shade in? Exactly, 5 more parts. So I'm going to shade in 5 more. There's 3, 4, and 5. So I have 7 shaded here plus 5 more gives me my 12. So I have 12 shaded parts, and each model has 7 total parts. So now I've represented my 12/7. And the cool thing about improper fractions is that they can be converted or written as mixed numbers, where you can see how many whole models have been shaded and then the extra parts that are shaded in another model. So let's take a look at what mixed number 12/7 would be equivalent to. So how many whole models are shaded? Correct. There's one complete model that is shaded. So the whole number would be 1. Now, how many extra parts are shaded? 1, 2, 3, 4, 5. Correct. 5 extra parts are shaded. And again, our denominator always remains the same. It does not change because the number of parts in our whole models has not changed. So that denominator would stay at 7. So 12/7 converts or is equivalent to 1 and 5/7, giving me 1 whole model shaded and 5 out of 7 parts shaded in another model. Take a look at our next example. So here we have a mixed number, 3 and 2/5. So this is basically telling us that we have 3 complete models that are shaded, and then another model that only has 2 parts of it shaded. And again, our denominator lets us know how many total parts are in each model. So let's use our pen color to shade in our model. So we shade in 3 complete models. So I'm going to shade in 1 model. And this won't be entirely perfect. I just want you to get the basic idea of it. 2 models shaded. And as we notice, as we're shading, each model has how many pieces? Very good, 5 pieces. And 1 more complete model to shade in. So here we have our 3 models shaded that represents the 3 here, the whole number. So now we have the 2 parts shaded out of another model. Those are like our extra pieces. So I'm going to shade those in here. And I'm not shading the complete model because our fractional part tells us we only need to shade in 2 pieces. So now I've represented my 3 whole pieces here. 1, 2, 3. 3 whole models that are shaded. And then I've shaded in 2 pieces in the next model. So I have 3 whole pieces shaded, whole parts shaded, and then 2 of the next model. So we were able to, in the first example, show how that improper fraction was equivalent to a mixed number. Now we're going to do the opposite. We're going to show how this mixed number converts or changes to an improper fraction. So we're dealing in parts and pieces. How many individual parts or pieces are shaded? I have 3 whole models shaded, and there are 5 pieces in each model. So I have 3 times 5, giving me 15. Then I have 2 extra pieces here, and that gives me a total of 17 pieces that are shaded. So I have 17 pieces shaded. And again, what stays constant always remains the same. Our denominator. Very good, because there are 5 parts to every model. So 3 2/5 is equivalent to 17/5, or 17/5, meaning I have 17 total pieces shaded, and each model that I shaded in has 5 total parts to it. So this is a way that you can look at improper fractions and mixed numbers. And the cool thing about this method is that you can draw these models yourself. And whenever you test or have an independent assignment to do, you can always draw these models as a reference chart for your own use. So I hope you were able to see how we can change and convert improper fractions and mixed numbers, and how we represent our fractions in amounts that are greater than 1.